Welcome back, Algebra 1ers. Congrats on making it to Chapter 5, where we'll be working with linear functions, talking more about graphing, seeing how equations are graphed out, and all that good stuff. With 5.1, dealing with rate of change and slope, this is a really big topic in graphing, and we've actually seen it a little bit previously in Chapter 4, where there was one point where I was denoting the change in y over the change in x. And what that was really the slope of the type of line that we were graphing. The rate of change part is very similar, where it just shows relationships between changing quantities. So the rate of change is really the same idea here, the change in the dependent variable dividing with the change in the independent variable. A little bit of a spell check, but who's checking, am I right? So delta y over delta x, change in y over the change in x. So the change in the y coordinates dividing by the change in the x coordinates. When we graph these, we can compare rise and run, which is pretty much the steepness of the line, aka the slope. We can use 2 points on the line to find slope. So for this slope seen here, we have these 2 points marked out on an xy plane of -2, 2, and also 3, 2. Or sorry, 3, 1. So this is -2, 2. This is 3, 1. To measure the slope, we have to figure out the coordinates that we would have to take to go to this point. So what this means is that we can measure the change in x, so the difference from this x coordinate to this x coordinate. So let's do that. We would have to move over 1 time, 2 times, 3 times, 4 times, 5 times. So this is saying that our change in x is +5. And for the change in y, how many units would we have to go down from here to here? This would just be going down 1 unit. So our change in y is down 1 unit. Collectively, we can say that +5 was considered our run. -1 was considered our rise. Even though we went down, it's still considered the rise. So for this type of scenario, we would be able to say that the total slope, which is denoted as m, is going to be the rise over the run. So this would be -1 over 5, which would be considered the slope. We know that this is a negative slope because this is going down to the right. It's declining. So you always want to look for key context terms or clues like that. Since this is going down and to the right, it's definitely a negative slope, and it's not going super quickly, so it makes sense that it's approximately a fraction. So although we have the visual opportunity to change these points and see what the slope's going to be like, we also have a formula that's handed to us here, which is really crucial. So this is saying that given 2 points as ordered pairs, x1, y1, and x2, y2, we denote the slope as y2 minus y1. So we would take the y coordinates. So y2, put that first. We would take the y coordinate, y1, and subtract that. Always subtracting, that's a really important thing. Take away from this. We also see the x coordinates deducting in the denominator. Where eventually this will simplify into a fraction and sometimes be able to reduce even further, and we're always looking to reduce as much as possible and leave as a fraction if it's a normal kind of fraction that we can't simplify to a whole number. So with the points seen here, notice that these aren't graphed out, but we could totally graph them out if we needed to. Let's first denote what these points are. So let's call this one x1, y1, x2, y2. We could have swapped these out and called this x2, y2, and this x1, y1, but I think it's easier to just go from left to right. So we're taking y2 minus y1, so 8 minus 6, dividing with 5, and we're subtracting what kind of 1 for x1? We're definitely subtracting -1. So notice with the arithmetic here, 8 minus 6, we can simplify that to 2. If we have 5 and we're subtracting -1, we can think of that as 6. Keep in mind positive 6. 2 over 6, can you simplify this further? Do these have common factors that we can simplify? You should be saying 1/3. So this would be considered our slope. I'll give you a moment if you want to try the next one. Pause the video, try this out with the coordinate -1, -2, and the second point -4, 1. The arithmetic would look something like this. 1 subtracting -2. Please be mindful of terms when they're negative. That's where I see students trip up a lot, so be mindful of the signs. Super crucial. So we have 1 subtracting -2, -4, subtracting -1. 1 minus -2 gets us 3. -4 subtracting -1 gets us -3. Can we simplify this further? 3 over 3 is just 1. But since this is a -3, make sure that it's a -1 altogether for the slope. For the next example, if you want to pause it, try it out real quick, go for it. We see we have -3 subtracting -2, -8 subtracting -4. -3 minus -2 gets us -1. -8 minus -4 gets us -4. So although this is a fraction of just pretty much 1/4, can we simplify the signs at all? Can we do that? We definitely can, because notice that this is a -1 and a -4. These are both negative, so we can definitely just get rid of those and say our slope's positive 1/4. And that's totally fair game to do that. So what would these look like when they're graphed out? If we had something that was positive, like 1/3, this would be moving up and to the right. -1 would be going down and to the right, showing a decline. And 1/4 would be going up and to the right. Not super fast with these types of slopes, but they would still be going up and to the right. That being said, we'll see for some situations like 4 and 5, it doesn't always just go up and to the right or down and to the right. So with these 2 points seen here, taking the same kind of song and dance, we'll do 7 minus 5. And then in the denominator, 4 minus 4. But notice, what's interesting about this problem? What repeats? Or what's going to happen with this arithmetic? You should notice that 7 minus 5 gets you 2, no matter what, but 4 minus 4, that gets you 0. And if you try to simplify this further on a calculator, 2 dividing by 0, you get that this is not a number. So what this means, if you ever have to divide by 0, is that this is an undefined slope. So think about how this would look when it's graphed out. 4, 5, and 4, 7. It would look something like this. 2, 3, 4, 5, 6, 7. You would see that the only way that you'll have a line to show this is if it's a straight vertical line. And that's the only way that's going to work. So this is a peculiar type of situation, but it definitely comes up. So you have to be on the lookout for that. I'll give you a moment to try the next one. What do you think that's going to be like? Well, you know, same kind of song and dance. We've done 6 of these problems now. You would have this 2, subtracting this 2. you would have negative 1 subtracting 1. 2 minus 2 gets you 0. Negative 1 minus 1 gets you negative 2. And so you might be thinking, well, isn't this the same kind of fraction that we already saw? Well, potentially, but what's different? So notice that the previous problem had 0 in the denominator, whereas now 0 is in the numerator, meaning the top of the fraction. So we're actually allowed to say that this can simplify to 0. And if you're not convinced, you can try this on a calculator. So we'll take 0, we'll divide it by negative 2. A little bit of a typo. It's Saturday, so I'm allowed to make a little bit of a mistake. To make that negative, we see that this simplifies to 0. So we're allowed to rewrite this as a slope of 0. And in this case, if you think about how this will look when it's graphed, since the y-coordinates are the same, it looks something like this. 1, 2 is here. Negative 1, 2 is here. So what kind of line is this? Is this vertical, horizontal, left, right? What do you think? So notice that this is definitely a flat horizontal line when these are graphed out because the slope is 0. So even though we associate 0 with nothing, this implies that as far as slope, it's not moving up, it's not moving down, it's very consistent, it's very flat, it's very boring, which is just okay because sometimes with slope, we'll see a variety of options that come up. Positive, negative, undefined, and 0. Be on the lookout for them. If you're stuck on something, please ask a question in class or shoot me an email. Thanks for watching.